In 2017, a Stanford neuroscientist named Andrew Huberman published a paper on the relationship between light exposure and the human circadian system. The finding was not new. Researchers had known for decades that light entering the eyes in the morning triggers a cascade that sets the body's internal clock. What was new was the precision. Huberman's team demonstrated that specific wavelengths of light at specific intensities within a specific window after waking could measurably shift cortisol release, melatonin suppression, and alertness patterns for the rest of the day. The window is approximately 90 minutes, and what happened inside that window, or failed to happen, had consequences that extended well past noon. This is not a morning routine video. This is a video about what your brain is actually doing in the first 90 minutes after you open your eyes, and 3 practices that work with that biology instead of against it. But first, a question worth asking. Why do most morning routines fail? Not eventually, quickly, within a week or two. The usual answer is discipline, willpower. You were not committed enough, not consistent enough, not serious enough about change. And that explanation sounds reasonable until you notice that it applies to almost everyone. Millions of people have tried a morning routine. The vast majority abandoned it. At some point, the explanation stops being everyone lacks discipline and starts being the design is wrong. And the design is usually wrong for a specific reason. Most morning routines are built around ideology, not biology. The 5 a.m. Club is not based on circadian research. It is based on a productivity narrative. Cold showers have real physiological effects, but the claim that they reset your nervous system every morning is not supported by the kind of evidence that would survive peer review. Journaling. What Am I Grateful For has some data behind it, but the effect size is modest and the mechanism is poorly understood. The problem is not that these practices are useless. The problem is that they are prescribed without reference to what the brain is actually doing when you wake up. And what the brain is doing when you wake up is not nothing. When you first open your eyes, your brain is in a state called sleep inertia. This was studied extensively by Thomas Balkin and colleagues at the Walter Reed Army Institute of Research. Sleep inertia is a measurable period of impaired cognitive function that lasts between 15 and 60 minutes after waking. During this window, your prefrontal cortex, the part responsible for decision-making, planning, and executive control, is operating at significantly reduced capacity. Your reaction times are slower, your judgment is worse, your working memory is compromised. The research is specific. In the first 30 minutes after waking, cognitive performance can be lower than it is after 24 hours of total sleep deprivation. This is not laziness. This is neurobiology. And it means that any morning routine that requires complex decisions, intense willpower, or high-level thinking in the first 30 minutes is fighting the brain instead of working with it. At the same time, something else is happening. Within the first 20 to 30 minutes after waking, the body produces what is called the cortisol awakening response, a sharp spike in cortisol levels that is distinct from the stress-related cortisol most people associate with the word. This spike was studied by Ines Wilhelm and colleagues at the University of Trier. It serves a function. It promotes alertness, mobilizes energy, and helps the brain transition from the disengaged state of sleep to the engaged state of waking. The cortisol awakening response is not a problem to be fixed. It is a signal to be used, and what you do during this window, roughly the first 60 to 90 minutes, can either support that transition or disrupt it. Scrolling a phone screen in bed disrupts it. Lying in a dark room for an extra 20 minutes disrupts it. Jumping into a cold shower creates a cortisol spike on top of a cortisol spike, which can amplify anxiety in people who are already cortisol sensitive. The biology has preferences, and the biology does not care about your morning routine Instagram post. So what does work? 3 practices, each with specific peer-reviewed evidence. Not because 3 is a magic number, but because these 3 target different systems in the brain and body, and together they cover the critical window. Practice 1, deliberate morning light exposure. This is the most well-documented intervention for morning neurochemistry, and it is also the most underestimated. probably because it sounds too simple. The mechanism works like this. When light enters the retina, specifically, when photons hit a class of cells called intrinsically photosensitive retinal ganglion cells, it sends a signal through the retinohypothalamic tract to the suprachiasmatic nucleus, the brain's master clock. This signal does two things. It suppresses melatonin production, and it anchors the timing of the cortisol awakening response. When this signal is strong and consistent, the entire circadian system synchronizes. Sleep quality improves. Daytime alertness increases. Mood stabilizes. When the signal is weak or absent, because you stayed indoors, wore sunglasses, or looked at a screen instead of the sky, the clock drifts. And a drifting clock produces fragmented sleep, sluggish mornings, and the kind of afternoon fatigue that no amount of coffee fully fixes. The protocol is straightforward. Within the first 30 to 60 minutes of waking, get outside. Not through a window. Glass filters the wavelengths that matter most. Direct outdoor light, ideally sunlight, for a minimum of 10 minutes on a bright day and 20 to 30 minutes on an overcast day. No sunglasses. You do not need to stare at the sun that would damage the retina. Just be outside with your eyes open. Figueroa and Rea at the Rensselaer Polytechnic Institute published data in 2010 showing that even overcast outdoor light provides significantly more of the relevant wavelengths than indoor artificial lighting. The intensity matters. The timing matters. The consistency matters. And the effect is cumulative. This is not a one-day fix, but a pattern that builds over weeks. Practice 2, physiological sighing. This one is recent, specific, and remarkably efficient. In January 2023, a study from the Huberman Lab at Stanford, led by Melis Yilmaz-Balban and colleagues, compared 4 daily interventions: mindfulness meditation, cyclic hyperventilation breathing, cyclic physiological sighing, and a control condition. Each was practiced for 5 minutes per day. The result, cyclic physiological sighing, produced the greatest improvement in mood, the greatest reduction in respiratory rate, a marker of autonomic calm, and the greatest reduction in anxiety. Greater than mindfulness meditation. In 5 minutes. The technique is simple. 2 short inhales through the nose. The first fills the lungs partially. The second tops them off completely, followed by 1 long, slow exhale through the mouth. Repeat for 5 minutes. That is it. The mechanism is not mysterious. The double inhale maximally inflates the alveoli, the tiny air sacs in the lungs that had collapsed during normal breathing. This increases the surface area for gas exchange, which allows more carbon dioxide to leave the bloodstream on the exhale. The drop in carbon dioxide triggers the parasympathetic nervous system, the rest and recovery branch. Heart rate slows. Blood pressure drops. The subjective experience is a rapid, noticeable shift from activation to calm. This is not a relaxation technique in the vague sense. This is a specific physiological lever. And it takes 5 minutes. During the sleep inertia window, when the prefrontal cortex is not yet fully online and complex practices feel impossible, 5 minutes of deliberate sighing is doable. And the data says it works. Practice 3, expressive writing. This is the oldest of the 3, and probably the most underused. In 1986, James Pennebaker at the University of Texas conducted the first controlled study on what he called expressive writing. Participants were asked to write for 15 to 20 minutes about their deepest thoughts and feelings regarding a stressful or traumatic experience. Not a gratitude list, not affirmations, the raw, unfiltered content of what was weighing on them. The results, replicated across dozens of studies over the next 2 decades, were consistent. Expressive writing reduced intrusive thoughts. It improved working memory. It decreased visits to the doctor. It improved immune function. A follow-up study by Mel Madrona and Pennebaker in 2006 showed that participants who wrote about their anxieties before a high-stakes event performed measurably better, not because the writing eliminated the anxiety, but because it externalized it. The intrusive loops, the same rumination circuits from the first video in this series, were given somewhere to go. Instead of cycling endlessly inside the default mode network, the thoughts were transferred to paper. The network quieted. Cognitive resources were freed. This is not journaling in the Instagram sense, pretty notebooks and reflective prompts. This is closer to drainage. 15 minutes, a blank page, and the instruction: write whatever is taking up space in your head. Do not edit. Do not plan to show it to anyone. Do not reread it. The practice works because it gives the mind a way to complete the processing loop that rumination never completes. Rumination circles. Writing moves forward, even when it is messy, even when it goes nowhere coherent. The linear act of putting one word after another forces a kind of sequential processing that circular thinking, by definition, cannot achieve. Now, here is what does not work and why. Not because these practices are worthless, but because the claims attached to them do not hold up under scrutiny. Cold showers have a measurable effect on norepinephrine and dopamine. Schramek and colleagues showed this in a 2000 study using cold water immersion. The increase is real. But the claim that a cold shower every morning resets the nervous system or builds mental toughness is not supported by longitudinal data. What the data actually shows is an acute stress response followed by a return to baseline. For people with high baseline cortisol, chronic stress, anxiety, poor sleep, adding another stressor in the first 30 minutes of the day can amplify, not reduce, the feeling of being overwhelmed. Cold exposure has its place. That place is probably not the first thing you do while your prefrontal cortex is still booting up. Affirmations, repeating positive statements to yourself, have a complicated evidence base. A study by Wood, Perunovich, and Lee in 2009 found that for people with low self-esteem, positive affirmations actually made them feel worse. The proposed mechanism: when the affirmation contradicts deeply held self-beliefs, the mind generates counter-arguments which strengthen the negative belief. For people who already feel reasonably good about themselves, affirmations had a small positive effect. The takeaway is not that affirmations are useless, it is that they are not universal, and prescribing them as a morning ritual without understanding who they help and who they hurt is irresponsible. The 5 a.m. wake-up has no inherent advantage over 6 a.m. or 7 a.m. Circadian chronotype research, Roenneberg and colleagues, published extensively from 2004 onward, shows that biological wake times vary by roughly 4 hours across the population. Forcing a late chronotype to wake at 5 a.m. does not create discipline. It creates chronic sleep deprivation. And chronic sleep deprivation degrades every cognitive function that a morning routine is supposed to improve. The best wake-up time is the one that gives you 7 to 9 hours of sleep and allows you to be outside within the first hour. That is the evidence-based answer. It is not glamorous, and it does not make a good book title. Here's the thing that ties all of this together. A morning routine is not a performance. It is not a signal of how serious you are about your life. It is a set of conditions you create so that your brain has the best possible start. Light to set the clock. Breathing to calm the system. Writing to clear the loops. These are not rituals. They are interventions. Each one targets a specific mechanism. Each one has a specific evidence base, and together they take approximately 30 to 40 minutes, not because that is a nice number, but because that is roughly how long sleep inertia lasts and the cortisol awakening response needs to stabilize. There is something worth noting about all three of these practices. None of them require motivation. Light exposure requires walking outside. Physiological sighing requires breathing. Expressive writing requires a pen and something to write on. The barrier is not willpower, it is information. Most people do not do these things because nobody explained why they matter, what they do, and how they connect to the neuroscience of waking. That is the design problem, not a character problem, not a discipline problem, a design problem. We have spent 3 videos now building a foundation. How the brain gets stuck in loops. Why observation alone is not enough. And now, what the first 90 minutes of the day can do to support everything we have talked about. But there is a reason we are going somewhere different next week. Because everything we have discussed so far, the techniques, the science, the tools, assumes that the goal is clarity, calm, presence. And for most people, it is. But there is a version of this path, a version of detachment, of letting go, of non-reactivity that goes too far. Where letting go stops being wisdom and starts being escape. Where calm becomes numbness. And where the advice that was supposed to set you free quietly locks you in a different kind of cage. That is where we are going Tuesday. And it is the part nobody warns you about.